Hi, ladies and gentlemen. This is Mrs. Poland, and this video is Unit 6, Lesson, it's actually 14, and it's actually our first day of two-proportion z-test. So example 1. The student council at a large high school is wondering if juniors or seniors are more likely to attend the prom. They take a random sample of 50 juniors and find that 28 of them are planning on attending the prom. They take a random sample of 45 seniors and 29 are planning on attending. Does the data provide convincing evidence that a higher proportion of seniors are going to the prom than juniors? Use a significance level of 5%. So they want a hypothesis test, and since we're dealing with two distinct populations, juniors and seniors, we're actually looking at a two-proportion z-test. So the steps are pretty much what we've been doing, and so our very first step is to state a parameter. So when we're comparing two proportions, we're actually going to use the difference. So P1 minus P2. Note, we're not going ahead and giving them hats. And so let's define what those proportions are. So P1 minus P2 is the true difference in proportions between juniors and seniors who plan to attend the prom. Now, we should be a little bit more clear which one represents the juniors and which one represents the seniors, and it really doesn't matter which you choose. You just want to be consistent with your work. So I'm going to let P1 equal to juniors, so the proportion for juniors, and P2 represent the proportion for the seniors. And I clearly let the reader know in that statement. The next thing you're going to do is you're going to define your null and your alternative hypothesis. So there are two ways of writing the null hypothesis. The first, which is the most common, is to say we're going to assume that there's no difference between the numbers. So almost always in the null hypothesis, you're going to be setting it equal to something. In this case, we're setting really P1 equal to P2. By the way, that's the second way that you can write that null hypothesis, just saying the two proportions are equal. The alternative hypothesis, in this case, since P1 represents the proportion of juniors, by the way I've defined it, and I'm looking to see if there's a higher proportion of seniors versus juniors, then I would expect that my difference to be negative, so it's less than 0. Again, another way of rewriting the alternative would be P1 is less than P2. Notice there's no hats in the null or the alternative hypothesis. The next thing you should clearly do is define your significance level. In this case, they give it to us, but if they didn't, you could choose anything. And although it's not mandatory to include in this section, I would highly recommend calculating P1 hat and P2 hat so you have that information readily available. So P1 hat is our juniors, our sample proportion of our juniors. That's our evidence, and that's 28 out of 50. And as a decimal, this would be 56%. And P hat 2 would be 29 out of 45, which expressed as a decimal is 0.64. So we can see that the difference in the sample proportions, P hat 1 minus P hat 2, is 0.56 minus 0.64, or negative 0.08. We're up to step 2, and that is our proportions. Or verifying our conditions. So what is our first condition? Put the video on hold and write it down. If you said 2 independent random samples, you would be absolutely correct. It's really critical that when you're doing that first condition, since you're dealing with 2 proportions, you must clearly state that you're dealing with 2 distinct random samples. Otherwise, you will lose points on the AP exam. I'd like you now to put the video on hold and write down the second condition. So the second condition is the 10% condition. It is reasonable to assume that there are more than 500 juniors and 450 seniors at this large high school. The reason for this condition is since we're withdrawing without replacement, and we don't want one result to affect another result. The reason for the first condition is the random samples allow us to generalize to the overall population of interest, which in this case is the large high school. So the last condition is the large count condition. Now, this one you have to be a little bit careful with. It's slightly different than our usual statement. So the large count condition is n times p, or is it n times p hat? So when we're dealing with a 1 proportion test, it's plain p because we define p within our null hypothesis. But if we go ahead and take a closer look in this scenario, so if we take a look at this scenario, we don't know what P1 is. So we actually can't use P in this case, and what we're going to end up having to use is P hat. So because our null hypothesis no longer defines P1 itself, we must use the next best thing, and that would be P hat 1. So I'd like you to do the success failure condition for both the juniors and the seniors. So put the video on hold and then you could check your answer. Did you match the answer? Great job. The reason for the large count condition is that it enables you to apply a normal model when you're calculating your p-value. The next step is to actually name that test. And so I want you to put the video on hold and write it down. So did you say since conditions have been met, we can perform a 2 proportion z-test? Good job. Just an interesting note for those of you who are using Kami. You may not be aware, but if you create a text box, if you look at the toolbar, there is, hold on, where is it now? Oh, all the way to the right next to the undo button or rotate button, there is actually a record button. I use that to voice to text. So you may want to try that. You just have to kind of train it because otherwise you're going to get some funny words there. Okay, so that's just an interesting side note. Okay, so now we are on step 3, which involves the actual calculations. So let me get my drawing tool out. And so step 3. And here is where there's a little bit of a difference. Okay, again, since we're dealing with proportions, we're using a z-statistic and a z-test statistic rather. And the next thing you want to do is enter the statistic minus the parameter over the standard error. Well, the statistic is the P1 hat minus the P2 hat. The parameter is P1 minus P2. And now we have to look up to the standard error, and here's where the difference lies. So we're going to the reference sheet, which, as I've always said, you want to make sure you have handy. And we want to slide down to the sampling distribution of the statistics. And there's again our test statistic there, but we're going to slide further down into the section of random variables and parameters, and we're dealing with two proportions. We have two standard error formulas. So for the first formula, look at the difference. We use that for confidence intervals. But for two proportion z-test, we actually don't use that pq over n and p2q2 over n. Instead, we pool, and we pool because in our null hypothesis, we are assuming that P1 minus P2 is equal to 0, or in other words, that P1 is equal to P2. So therefore, our variations have to be the same, and we do something called pooling. So the formula we're going to end up using for the standard error is the square root of a p hat pooled, and I'll show you how to calculate it, q hat pooled, times 1 over n1 plus 1 over n2. So I'm going to show you how to pool. You're basically doing what we tell you never to do in the math. You're adding your numerators and adding your denominators. Okay, so let's go back to our notes on this lesson. Okay, so we're going to pool, and I'm going to show you how we get that pooled statistic. And so it's p hat c, q hat c, 1 over n1 plus 1 over n2. (57 over 95), which turns out to be 0.6. So we know that we have 0.56 for P1 hat minus 0.64 for P hat 2. This parameter we take from the null hypothesis, and almost always, not always, but almost always, like 99% of the time, it's just going to be 0. Over the square root, now we're going to use our pooled value of 0.6. Q hat c is 0.4, and it's 1 over n1, which is 50, plus 1 over 45. And instead of calculating this by hand, we're going to actually use the calculator. So we're going to go into our calculator, into a calculator page, and you're going to hit menu, 6 for statistics, 7 for stat test, and we're doing a 2 proportion z-test, so that's item number 6. So we're going to enter the junior amounts, which is 28 out of 50, and we're going to enter 22, not 22, it was 29 out of 45 for the seniors. Make sure to change your alternative hypothesis. Remember, in this case, our alternative was the juniors less than the seniors, so this last one, and you're going to hit OK. And it gives us our test statistic. It gives us our p-value. It gives us, notice the p hat 1, that's actually our pooled value. And so let's place this on our sheet. You get a value of negative 0.8389. That's our test statistic, or z value. I guess I should write z equals. And we're going to draw our diagram. So the mean is just the parameter, so it's P1 minus P2, or 0. We ended up getting a difference. Actually, it's negative because we're looking at the juniors first, so it's negative 0.08. And we're going to be calculating our p-value. So we want to find out the chance that we get negative 0.08 or less. Okay, so let's go back to our drawing tool. And so we're going to calculate the p-value by hand. So you're looking at the probability that our test statistic, which is p1 hat minus p hat 2, is less than negative 0.08, which is the same thing as the probability that our z-statistic is less than negative 0.8389. And then you're going to do normal CDF, negative 9E999, negative 0.8389, and then it's going to be 0, 1. And let's enter that in our calculator just to confirm. In actuality, you could just put down the p-value on the actual AP exam, but on the upcoming test, I'm only giving you one problem. I actually want to know you know how to calculate it by hand. So you would do menu, statistics, distributions, normal CDF. We have our lower bound as default. And when you get it, and when you enter it in the calculator, it's essentially 0.201. And so that's how you would calculate the p-value by hand. Okay, I promise you I'll show you shortcuts for the actual AP exam, but for now I need you to know how to do it, especially for the multiple choice. So we're up to our last and final step. And although I want you to interpret the p-value on your actual test, upcoming test, just to save some time, since this video is getting a little long, let's just write the general conclusion. So put this on hold and try. Did you get the following statement? Since the p-value of 0.201 is greater than alpha of 0.05, we fail to reject HO. We do not have convincing evidence that the proportion of seniors who plan to attend the prom is greater than the proportion of juniors. By the way, I use the that text tool over there. It's very nice. So I definitely need it to be trained a little bit more. I hope this video helps, and I will see you tomorrow.